Year 7, we're going to continue our work on decimals today, but in particular a special type of decimal. Sometimes when you divide a number and find the decimal answer, you end up with a decimal that just keeps on going and going and going, like this one here, 0.3333, and it would just keep on going forever. That's a third. So we can actually shorten that, and if you write 0.3 with a dot above it, or 0.3 with a straight line above it, people in the world know that means that decimal goes on forever. That's a recurring decimal. But notice that the accent, that's the dot or the line, only over the repeating digit or digits, which we'll see with this one when we get to it. Okay? That's where it goes. Don't put it anywhere else. There's two definitions we need to know. Firstly, a terminating decimal is one that has a definite number of decimal places. It stops. Whereas a recurring one just keeps on going and going and going and repeating. All right? Those two terms are important to know. So let's look at these three examples I've got here. Question 1 asks us to convert 5/8 into a decimal. Now, I wanted to make a side point here. When I was in year 6, I can remember my year 6 teacher taught me that I should actually learn what certain decimals are. He taught me, make sure you know what half is as a decimal. We should all know that's 0.5. Make sure you know what a third is, which is this one, 0.3 repeater. Make sure you know what a quarter is. 0.25, 0.5, 0.75 for 3/4. He then said, make sure you know what a fifth is. 0.2, 0.4, 0.6, 0.8. 1 is 5/5. A sixth, not so important. Still could be helpful, and we'll deal with one here. A seventh, not worth, because it's just too complicated, all right? An eighth, though, that's half of a quarter. So 0.125, 0.25, that's 2/8. 0.375, 0.5. Okay, that's 4/8. 5/8, 0.625, 0.75, 0.875, and then up to 1. I have found down through the years, by knowing and just learning those off by heart, when I've come across questions like this, I'm pretty quick to know what I need to do. Yes, it's a little bit of a side discipline, but I encourage you to have a go. See if you can learn those decimals from 1 through to probably tenths, and you can ignore 6ths, 7ths and 9ths, and you'll probably do quite well. Have a go at trying to learn those off by heart. So here we have 5/8. I already know the answer is 0.625 because I just know that fraction. But let's do the maths and show what we need to do. So we're finding out 5 divided by 8. So it's 8 into 5. As we learnt yesterday and should know, it won't go there, so put your decimal point, add a 0. So know it's 0. We then do 8 into 50. 6/8 are 48. So it goes in 6 times and there's 2 left over. We then do 8 into 20, which goes twice with 4 left over. And then 8 into 40 goes 5 times. So we have 0.625. Tell me, is that a terminating or a recurring decimal? Yep. It is a terminating, all right? It's stopped. It's been terminated at that point. The train line has ended. Doesn't go any further. No. All right? But when we come to question 2, we're going to see a difference. The question is 5/6. So again, write it as this sort of question, where like a short division, and you should be able to see straight away, I'm going to need some zeros. I'll put a few in because we're going to go for a little while. How many times does 6 go into 5? Thank you. I saw someone showing me with their fingers. Well done. 0. We've got 5 left over. All right. 6 into 50. Yeah, it is 8 times. Well done. 6/8 are 48, so there's 2 left over. 6 into 20. Yeah. Yep, it goes 3 times. How much is left over? 2. Great. 6 into 20. Yeah, have we done this one before? What's left over?
2.
Oh, hang on, 6 and a 20. 3 with 2 left. It just keeps going, doesn't it? We're just going to keep doing the same thing again and again and again and again. It's called a recurring decimal. So we can shortcut this by saying 5/6 is equal to 0.83 with a dot, or with the accent, with the straight line. You only put it over the 3. Do not put it over the 8, because it's only the 3 that keeps getting repeated. All right, question 3. 2 11ths. Anyone know what an 11th is? Do you know? No? Yeah, good. I didn't think you would. So we need to have a go at it. All right? Because I would think actually, that's a good point. If he did know what it is, I'd just be amazed. But good means that he just hasn't managed to explore it yet. I get to teach. Yeah, that's it. Thank you. Good. I get to teach you more. All right. Does 11 go into 2? No. So just like we've been doing, put down your decimal point. How many times does 11 go into 20? 1. Good work. Okay. What have we got left over? 9. Good. You're on fire here. All right. 11 into 90. 8. Great. With 2 left over. Okay. 11 into 20. 1. What's left over? 9. Hang on a minute. 11 into 90. 8. Remember 2. Oh, hang on. 11 into 2. Once with 9 left over. 11 into 90. Notice we're getting a recurring pattern, or a repeating pattern. Again, it's just going to keep going like that. So instead, what we can do, we can simplify it. 2 11ths is equal to 0.18. And when there's 2 numbers repeated like that, or if it's 3, you put the dot above the first and the last number. All right? Or you could also write it 0.18 with the straight line. So that's how we do recurring decimals. We shortcut our work, and if you do that, people know that you actually know what's going on. Because if you wanted to find the end, you would just keep on going, and it would never end.
Because mathematicians are lazy.
Exactly. Mathematicians are lazy and like shortcuts, but then we know what's actually there.
Is that why you like shortcuts?
I love shortcuts, all right? That's what maths is all about, finding shortcuts to find out better things. All right, we need to...
Reverend.
Thank you.
You can't shortcut then, can you?
We need to get in there and do a whole lot of practice. You guys are going to focus today. Let's get to it.